So what is a principal angle exactly? Let me extend this up a little bit. Many angles can have the same trig value. So we see this in the sine function, that sine of 30 was 1/2, sine of 150 was 1/2, sine of 330 was 1/2. So lots of angles. So all these red points represent 4 angles that all have the same trig value of 1/2. But every angle has only one trig value, so it's still a function. But what if we're talking about an inverse function? So in the inverse function, we know that each input can only have one output. This would be the input. And so that means each trig value can only have one angle, which is the output. So what do we do with this situation where we have multiple angles that all have the same trig value of 1/2? We have to limit it to only one angle that has a trig value of 1/2. So when we do the inverse function and 1/2 is our input value, y can only equal one of those angles, and the angle that it equals is 30 degrees. We found out earlier when we were talking about the sine function. This is known as the principal angle. Now when we look up at our sine function, we see that the principal angles appear to be in this region. Whenever we put in 0.5, we got 30 for inverse sine. Whenever we put in negative 0.5, we got negative 30. So we were seeing these two angles, 0.5, 30, and negative 0.5, negative 30. And so it appears that we're using this region of the graph. To double check that, we could also do inverse cosine of inverse sine of -1 and inverse sine of +1. So let's try that. Inverse sine of -1 and inverse sine of +1. These would give us the angles that are the endpoints of the principal angles that we've been using. Okay, so let me clear history and let's delete this. And clear the history here. There we go. All right. So if we do inverse sine of -1, we get -90. And if we do inverse sine of +1, we get +90. And if we do inverse sine of 0, we get 0. So this gives us 3 more key points to just verify that that is the section of the graph that gives us our principal angles. So here we have the point 190. Here we have the point -1, -90. And here in the middle we have the point 0, 0. And so that clearly is the section of the graph that gives us our principal angles for inverse sine. Now let's go ahead and talk about the domain and range of the sine graph. So if you look up on your notes to the first graph on the left, the regular sine graph, you'll see that the domain is the angles. And we can have any angle. That can keep on going forever. So we can go from -infinity to +infinity with our angles. The range are the trig values, the sine values, opposite over hypotenuse. And they can only go from -1 to 1 because the opposite side can't be bigger than the hypotenuse. Now when we do the inverse function, domain and range switch places. So now the domain is the trig values. And so our trig values are -1 to 1 for sine. The range are the angles, but we can't use all the angles or it wouldn't be a function. We can only use the principal angles. The one angle, the set of angles that I get so that there's only one angle for every trig value. So the principal angles are only between -90 and 90. If I'm in radians, then that would be -π/2 to π/2. Or if we're in decimal form for radians, that would be -1.57 to 1.57. Now, thinking about inverse sine, let's take a look at our little circle diagram that we've been using for so long. If we're looking for a positive sine, an angle that has a positive sine value, we could just look in quadrant 1 between 0 and 90. If we're looking for an angle that has a negative sine value, that would have to be in quadrant 3 or 4. But we want to pick the principal angle that is closest to 0. We want to pick the angle the closest to 0 to be our principal angle. So we're going to go backwards into quadrant 4 to find angles that have negative sine values. And so we're going to be going from 0 to negative 90. If we went to quadrant 3, that would take a lot longer to get there. Or if we went all the way around to quadrant 4 using positive angles, that would take longer. So we want the closest way to get to positive and negative values for inverse sine. Plus, it's really helpful to include the origin in the graph.